Hello, this isn't the normal video, but I thought I'd do something different recently. I'm in the middle of my exams and I have a Further Mechanics 1 test on the 6th of June, which is in just over a week's time from when this video has been released, and so I thought I'll do a run through of the paper. Before we start, I have some little disclaimers. Firstly, there are some cuts, which is mostly from where someone DM'd me or I had to stand up. But apart from that, it's just a total clean run through of the paper. Secondly, I have pretty bad hay fever and it's that time of the year again. So I think I sneezed or sniffled many times during the paper, so I'm really sorry about that. Thirdly, the paper was marked by my friend Rank on PvP, and I've attached the paper, the mark scheme, and some additional notes that he made in the description of the video. Big thanks to him. He gave me a pretty decent score, and I'm hoping that that's on track for my goals. And finally, do join my server if you want to see me do any more past papers or any other type of content at all. And without further ado, let's get into the paper. So here we have June 2019, Further Mechanics 1. Nothing really special about this one. We're gonna try to get, hold on, I should probably push the camera back or push the paper back. We're gonna try to get 4 marks if we can. Totally, that's what I'm aiming for. Yeah. Alright. I can't tell if you can hear me or not. I think you can.
I can.
Alright, cool. I think we begin. So I just make sure I have my pencil, calculators on, I have my formula book for all the last minute exam checks. I'm not going to bother to read out the exam paper, that's a bit stupid. that would be silly. Alright.
I can read.
You can see it, right?
Yeah.
Okay, yeah. There's... I don't know, I'm not really happy with these, but if you want to like interject in the middle, you can, but it's probably just gonna be me saying this is easy, this is hard, or I have no idea. Right. I think that's enough.
Okay.
That's enough deliberating. Let's begin. Timer starts now. Question 1. Okay. This one's pretty bad. Probably the restitution. Use 2/3. Walls are 3 meters apart. Okay. Where is O? We don't know where it returns. Okay, so we can just check after the first collision. So it bounces off at U meters per second, and it would come back at 2/3 E. That's obviously 2/3 U. That's collision 1. And there's no like air resistance, so after the second collision, we will have it bounce off. It's gonna go like this. So it will come in at 2/3 U, and it will come back at 2/3 square, which is 4/9. Let's check. Yep, 4/9 U. So in total, it spends it does no. So first distance, it moves d meters at u meters per second, then it moves 3 meters at 2/3 meters per second, and then it's going to move 3 minus d meters at 4/9 meters meters per second. So using speed is distance over time. This time is, or speed is distance over time, so time is equal to distance over speed. The first time is just going to be d over u. Second time is 3 divided by 2/3, which is just 2/3 u, which when you multiply top and bottom by 3 gets 9 over 2u. And then T3 is going to be 3 minus d over 4/9 u. 3 multiply top and bottom gets 27 minus 9d over 4u. Add them all together. T is equal to d over u plus 9 over 2u plus 7 minus 9d over 4u is equal to 4d plus 4u plus 18 plus 4u plus 27 minus 9d over 4u, which is 45 minus 5d for you as required. Okay, part B, 4 minutes down. Find the value of u is fixed. The particle still hits each wall once, but the value of d can now vary. Find the least possible value of t. Hold on. 1b. Since the value of d can vary, and it still has to hit each wall once, so we know that obviously u has to be greater than 0 for all u. Okay. Since d can vary, and obviously 0 to d to 3, the least value of t will probably be, well, we're moving the fastest when we're doing the first, so before the first bounce is the fastest we're going to be moving. So logically, the more time we spend on that first bounce, the better. Actually, no, I don't like that. I don't like that. If d was equal to 1.5 as an example, then t would be 45 minus 5 or 1.5 over 4u, which is 37.5 over 4u. But if d was 1 instead, then t would be equal to 45 minus 5 1 for u, which is 40 over 4u, which is 10 over u. 37.5 over 4 is obviously not 10 over u, it's a 9.375 over u. So since u is fixed, then this value is going to be bigger than this value, so we want to be maximizing. You want to maximize d, and so let d equal to 3. So t is 45 minus 5/3 over 4u, which is 45 minus 15, which is 30 over 4u, which is 15 over 2u, which is going to be our minimum least value. I think we're pretty good on pace. Let's move on to question 2. I don't know why that's happening. Question 2. Oh, great. Go to that 6. It hits AB and then it hits BC. So we have two triangles, which I should probably draw for alpha, beta. The alpha tan is 4/3, so 4, 3, 5 triangle. Oops. So we're doing some, and this one is 1 over 3, so 1, 3, 1 squared plus 3 squared is 10. So that's going to be root 10. Looks good. The coefficient of restitution between A and B is E. To show that, using our conservation of momentum linearly, because we know that that will not change. We have 6 cos alpha v equal to, which can put us v cos beta. So 6 cos alpha is 6 times 4 over 3 over 5, 18 over 5 is equal to v times cos beta, which is 3 over root 10. So we know that v must be equal to 6 root 10 over 5 meters per second. Then, using law of substitution vertically, we know that 6 sine alpha times negative e can be equal to v sine beta. 6 sine alpha is 6 times 4 over 5 times negative e, and sine beta is 1 over root 10, and we know what v is 6 root 10 over 5, so 6 times 4 over 5 is negative 24 over 5 e equal to 6 root 10 over 5 multiplied by 1 over root 10, 6, 5, which leads us to, if you divide 6 by 24, you'll get e is equal to a quarter. And I don't know why I had the negative sign, because obviously that was stupid. It's fine. Next part B, find the speed of the ball immediately after it hits PC. Now, to B, let's call this speed W, and we know what the angle is, and we know what the speed is, so it's just a case of another quick sketch. W, so 6 root 10 over 5. We have 2 angles. This one's beta, and this one's gamma. And what can we say? We can say that, okay, so you're using conservation of momentum this way. We have 6 root 10 over 5 times sine beta is equal to W times sine gamma. So W sine gamma is just going to be equal to 6 root 10 over 5 times 1 over root 10, which is 6, 5. Equation 1. Using law of restitution this way, because that's where the impulse would go. 6 root 10 over 5 times cos beta times a half times negative a half would be what? W times cos y. So W cos y is equal to all of that, 6 root 10 over 5 times by 3 over root 10 times by negative a half to give us negative 9.5, which is 2. So w squared is equal to 6y squared plus 5 squared. And 725. We must conclude that w is 3 root 13 over 5 meters per second. There's two ways in which the model could be refined to make it more realistic. Let's see. Model for air resistance and resistance of particle on the floor, so that speeds in between collisions would not be constant. Reason 2, model for energy loss. Energy loss in collisions, including heat and sound. I'm not really sure about the second one. Is there anything else I can possibly? Because we modeled them as being smooth, and the balls. Oh wait, the balls being modeled as a particle. Instead of modeling ball as particle, model as an object with dimensions to have more accurate representation of ball. $15 and roughly that amount of marks, I think. We're probably actually quicker than that. Right, you're going over here. Question 3. Okay, particle mass 0.5 kilos, moving with velocity 4.1. Before it receives a magnitude, then it's deflected at an angle of 49 degrees. Perfect. Before we have particle is moving along ij like that. P 0.5 g is the velocity of this, and receives an impulse of a magnitude that we don't know. And after, it's deflected at an angle of 45 degrees. So I don't think I can draw that accurately like this. So, oh wait, 45 degrees. That would make it, since it's already going at 45 degrees, that would make it be going vertically, like this. You don't really know that, but we do know that the chain, we do know that it's only traveling at I, so we know that. Oh, it's only traveling in the direction of J, so we know that I is 0. Oh wait, no, let's write it like this. Okay, and we know that the impulse was, we don't actually know anything about, we just know it's like some impulse at lambda. There's our picture, and lambda squared plus mu squared is equal to 2 root 2.5 squared, which is, oh, I just turned off my calculator. Beautiful. 2.5 squared, 6.25. Let's move. So, using I W minus NU, mu. There's possible pairs as well. Okay. 0.5 to V, which is 0V minus 0.5 plus u, which is 4. So it's equal to -2, and that's a half v minus 2. Okay, so we already know what that is, so we know that that's equal to -2, so that squared is equal to 4. 4 plus squared is equal to 6.25, so that's equal to 2.25. So mu is equal to, it could be positive or negative root 2.25. Positive or negative 3 over 2. Okay, so we have two impulses, or valid impulses that could work. -2, 1.5, and -2, negative 1.5. For case 1, you get 1.5 is equal to half v minus 2. That leads you to, and the reason for that is because it could also, as well as being deflected upwards, it could be deflected downwards, but the diagram only shows upwards, where it could be downwards. So 3.5 is equal to half v, so v is equal to 7. Right, 3.5 times 2 is 7. And in case number 2, we have negative 1.5 is equal to half v minus 2. So half v is 0.5. V is equal to 1. Okay. And just checking, that's going to give us what? 0, 1, and 0, 7. Oh, that doesn't make sense, because they're both deflected by because one of them is supposed to be going downwards. Interesting. There are 7. Both of them are going upwards. This one is going upwards slower. Let's take a look at our lambda equation. Lambda is what? 0.5, 0 times 0 minus 0.5. So that lambda always has to be -2. There's no doubt about that. But what if, yeah, we have two mu values, which is why one of them is going up, one of them is going down. That's the only way, right? So that's 2.5, so that's well, I can just write my mu pairs like what mu is, well, lambda is -2, mu is 1.5, lambda is equal to -2, mu is equal to -1.5, and we'll come back to that. But that's my answer for now. I don't think that's totally correct, but I don't want to waste too much time, so let's move on. So question 3. Question 4. Great. This is some work energy power. Question 4. Yeah, with a car and trailer along a straight horizontal road. So just 2 boxes. One's 600 kilos. One's 150 kilos. That's C, G, 52. Connected by a light and accessible tow bar. There's resistance and motion of the trailer of 200 newtons. And when in our model the speed of the car is v, and also the speed of the trailer is v, we know that there's a resistance to the car, which is 200 plus lambda v. We have the engine working at a rate of 1500 kilos, and when P is equal to 15,000, V is equal to 25. So V this way. We have using first law because there's no change, there's no acceleration, it's constant speed. E minus 200 plus. I haven't got my things on. That's not really great practice. No, I don't have my normal contact forces on anyway. E minus 200 plus lambda v minus 200 is equal to 0. Using P is equal to FV, 1500 is equal to E times 25, so E is equal to 600 newtons. Okay, so 600 minus 200 plus lambda times 25, that's 200 equal to 0. So that's 400, that's 200 times 25. 400 minus that's not particularly, I don't know, I don't like that, whatever. 5,000 lambda is equal to 0. So lambda is equal to 400 divided by 5,000, which is an eighth, not 8. What's gone wrong there? 400 divided by 5,000. No, it's not even an 8, it's 0.08. Alright, hold on. Force of E times 25, so we know that E is 600. We also know that 200 plus lambda V is 200 plus 25 lambda. And have I forgotten any forces at all? That's the resistance to motion. There's some tensions, but they cancel out in the thing. So what, 600 minus 200 plus 0 plus is equal to 400. 200 plus 25 lambda is equal to 400. 25 lambda is equal to 200. There we go. Lambda is equal to 8. Small hiccup, but it's fine. Now we have a part B. Later we have this thing just going up and angle this. Resistance to motion is normal constant force for the trailer at 200 newtons. And we're good. Put this down. Put this down. So quickly add on some. Trailer. RC, RT. It's the weights are still the same, so 600G and 150G. This one's 200 still. This one's 200 plus 8V. And we have speed of V. So when V is equal to 10, so I'm going to have this. When we put to 10, the turbo brakes, and then the trailer comes to instantaneous rest after moving the distance d of the thing. So that's after turbo brakes. We need to find the acceleration of the car after the turbo brakes. For that, we need to resolve again to find out what everything is. So using FV 1500 is equal to force of E times 10. So E is 1500 at the point when turbo brakes. Good. And also 200 plus 8V is going to be 200 plus 8 times 10. It's going to be 280. Then we can resolve parallel to plane. Using second, no. Using second law. We're trying to find. We get 1,500 minus. Okay, we probably want to find the tensions at some points, because that'll be helpful. 500 minus 280 minus 600 G times sine theta minus 150 G times sine theta minus 200 the total mass of 750 times the acceleration at the point where the tow bar brakes. Just plug all of those numbers into the calculator. Pretty much. 150 times 750A to 530. So is 53 over 75. .706 meters per second wide tracer. And then finally part C, work energy principle. So we need to think about the work done by friction. Just moving up the slope. This lace by itself. 200 distance of D, and it stops here. This is theta. And this is theta. So using the work energy principle, and we have initial KE to be, well, it's moving at 10 initially, and then it's moving at 0 here. A half times 150 times 10, which is 10 squared in fact. $7,500. Final K is 0. And initial DP equals to 0. Final DP is going to be equal to D sine theta. If this is theta, yeah, D sine theta is our height. Sine theta times mass of 150 times G, which is going to be equal to what's 150 times 9.8 times 1 over 15 plus 98 D. Okay. And work done by friction is, or by resistance in fact. Work is force over distance. That's 200 times distance of D, which is 200 D. So the loss in KE plus work done by resistance is going to be equal to that doesn't feel right. Mass gravitation times height d sine d to the 15th. 98d. Yep. I don't like that. It's because k is a half times mass times 10 squared. Yep. Okay, hold on. So what's going to be positive or negative by resistance? Well, I mean, okay, let's take it negative just a second. So 298d, 7500. So that gives us d is 25.16 meters. Or if it was positive instead, which wouldn't really make sense, or whatever. So mine's energy d is 7500. Which one makes more sense? I'm pretty sure it's the first one because it's only moving at 10. So yeah, I think that this one is a correct answer. Just by deduction. Yeah, you know, the alternative just wouldn't make sense. So, right. Onward we press. There's 7 questions. We've answered 4. 3 more to go. 1D collisions. 5A. So we're going to enable the P key. What do we know? Moving in opposite directions to each other. Before the collision, speed is u. To restitution of e. And after, we just have 2 seconds, which should actually know. V and W, I'm going to call them. Okay, so using momentum this way, 3m times u is equal to 2m times 2m plus 2m times v is equal to 3m times v, which goes to are both positive that direction. It doesn't really matter if they're not. They're probably not. Plus 2m times w. So what's that? 4m 3m 7m 3m 2w. So 2w plus 3v is 7v. Okay, then using law of substitution this way. W minus v, the top being u minus 2u, w and 2. Let's give you, so negative u w minus u, u minus w should be u. 52. We're trying to find the range of values of E. Knowing that it has to be range of E values. It tells us they're moving in opposite directions. I should have read the question properly. They're moving in opposite directions. Actually, no, we can. And V is negative. Yeah, V has to be less than 0 for this to hold. So let's solve simultaneously for V. We take a 2W equal to 7U minus 2U. So W 7 over 2U minus 3 over 2. So V minus W equal to EU. Substitute in V or W minus 7 over 2U. EU. 3 over 2 plus 1 is 5 over 2. Minus 7 over 2. U. Continue 5A. Let's multiply over 2. So 5V minus 7U. 2 E. 5V equal to 2E plus 7U. And you know that V is less than 0. So since V is less than 0, that means that 2EU plus 7 for V divided by 5 is less than 0. So if I take out a U here, 2E plus 5, 0, so 2E plus 7. 2E plus 7 must be less than 0. So that means 2E is less than 7. Negative 7 is less than negative 7 over 2. That makes no sense. That makes absolutely no sense. It's not even in the correct range. Let's check our substitutions again. Check 1 minus 3 over 2 is indeed 5 over 2. Not the biggest fan. Oh wait, we divided by U, but U could be... No, U has to be greater than 0. Yeah, the whole thing makes sense. That is why the prostitute is funny. Momentum for you. It's like so look at it. Further than you. I'll be minus 2. So that's 3. So either it's W is equal to 3EU. Then we just have to do that again. So lots of 3 EU plus V plus 3V 7U 6 EU plus 2V plus 3V plus 7U 5V plus 7U minus 6 EU to 2 lots of 7 minus 6E V equal to U lots of 7 minus 6E 5. As U is less than 0, that means that U and 5 lots of 7 minus 6E is 0. As U is greater than 0, then 7 minus 6E less than 0. So 6E is greater than 7 E is greater than 7 over 6. Still makes no sense. I think we're gonna write this E is less than 6/7. I think that's my right answer. Something similar. I'm not very happy about that one, but whatever. 5 B. During that loses 75% of its kinetic energy. So basically we have KE before 2m times 2u squared after times 2m times w squared. So that's obviously a half times 2 times 4, which is 4u squared. And that's just 4u squared m. And that's 2 maybe w squared m. So since it uses 75%, we can say that w squared m. So u squared m. No. 4 is equal to u squared m. W squared is equal to u squared. W is equal to u. So if w is equal to u, so it loses most of its k. So if w is equal to u, then u is equal to 3u plus v he is equal to negative. Okay, slow down. So e is equal to u minus v plus 3u. We'll do the equations for v in terms of u. We don't really. We kind of do actually. We can say that 3v is 7u minus 2u, 5u. So in which case that v is 5 over 3u. So that still gives us a nice answer. These 2 nights is what I've got from very messy algebra, lots of minus sign strokes. but I don't have the time to check it, so let's move on. Great, Lionel Smiths. Karma continues. Question 7 is strings and springs with double strokes. Okay, so I'm gonna need like 20 minutes for that, so let's try not to spend more than 15 minutes on this question. So I'm gonna be done by like 25 minutes left, so I have at least 10 minutes to check what I'm doing. Let's go, 41 minutes left. Great, it's parallel to that, so I don't have to do any manual tricks. Before we have 3i, that's 2j. And before here we have negative 4i minus j, which is like this. And we have e's. And this one is and after we have what I'm gonna call these two, which we don't actually know what the speed actually know what these are, but we can fill them in. So for obviously momentum this way is conserved. So this is 3 and this is still negative 4, I think. No, this way. So this is 2 and this is, why is it negative? Oh, I'm stupid. Hold on. That would cost me more if I didn't catch that. So it's actually going in like this. Negative 4, negative 1 like this. And it comes out like this. So we get rid of that. Negative 4, negative 1. And then after, it's coming out at negative 1 still. So we're going to call this one V, this one W. Alright. So that's one step already done. Using what should we call momentum this way. We have V times 0.2 plus negative 4 times 0.4 is equal to negative V times 0.2 plus W times 0.4. No sine angles to deal with. Negative 1 is equal to negative 0.2 V plus 0.4 W. Equation 1. Using the law of restitution, same direction. Negative 4 minus, it would be negative 4 because, yeah, okay, negative 4 minus 3 over UA, what am I actually doing? So that's what I'm drawing, so it would be V minus W, W minus V, UA is 3, minus 4, so 3/7 is equal to 3 plus W two equations, one in V, one in W, so we get to solve them. And I'm going to check that I solved them right afterwards, but I'm trying to find this. It doesn't really matter, we need to find both. W is equal to 3 minus V. 0.4 W is equal to 3 times 0.4. 1.2 minus 0.4 V. So negative 1 is equal to negative 0.2 V plus 1.2 minus 0.4 V. Negative 1 is equal to 1.2 minus 0.6 V. 0.6 V is equal to 1 plus 1 plus 2. 1 plus 1.2 plus, which is 2.2. So V is 2.2 divided by negative 0.6, or V is negative 11 over 3, and W is 3 plus 11 over 3, 20 over 3. And let's put that in my calculator just to check that I did solve the 17 equations correct. I'm not getting the same ones. I got 11. I got positive 11 over 3, not negative 11 over 3. Negative 0.2 plus 0.4 is negative 1. Yep. And 1 plus 1 is 3. So V is 11 over 3. W is negative 2, 3. We can just check that again. I'm just checking, it's quite useful. Yep. And just 3. Okay, yeah, we're cool. So the speed of level A final speed is equal to 11 over 3, which it should not be positive, it should be negative. You know what? Yeah, we're calling it negative. Yeah, they're both negative. And why is that? It is negative 11 over 3. I knew my calculator was tweaking, which means W is 3 minus, which is 20 over 3. So these are mistakes. Magnitude of the impulse, so we're nearly out of time already. Yeah. This is the impulse formula again. Minus 11 over 3 minus 3. And 2 minus 2 is 0 actually. So there's your impulse. So magnitude. And that makes sense. The size of the motion that A is turned. So basically it's going like this and then it's going like that. So we want to find this angle. This angle being theta. So this is 2, negative 3, negative 2. Because negative 3, negative 2 would be like that. No, yeah, negative 3, negative 2 is fine. I don't think that's fun actually. They're not both directly away from the point, so I don't really think. Oh wait, no, we can just find it. Okay, never mind. Screw the trying to find. So we can actually just find theta randomly. So we dot negative 11 plus 4, which is negative 7. 3 squared plus 2 squared times by 11 over 3 squared plus 2 squared. That's 13 times 3, so cos theta negative 7. 13 theta is 117 degrees. Oh wait, it should be like this, shouldn't it? 62.4 degrees. Question 7, let's get it done. And then hopefully if I get done in a few minutes, should be able to go back and try and figure out how to do some of the other questions. 30 minutes left, or 29 minutes now. Light spring. So if I fix my phone on the ceiling. Particle P is attached to one end of it. Natural length A. And initially we have this. Folder A released, so initial EPU, so GP doesn't, GP is anything that changes again. So initial EPU is going to be K1G times lambda x squared, which was a formula. X squared is 2a squared over 2 times A. This 4k which is just 2k and 2k. Final EPU 0, which is the slack by that point. Okay. Initial GP is 0. Final GP 0. Mass times gravitational force times distance gain, which is 2 plus a half. equal to 5/2 GA. It's not correct. And I don't know why that's not correct. Well, at rest A, first comes the instantaneous rest. It's a spring, not a string. Would that do anything bad? No, because like, oh wait, it's a spring, so the final EP is not 0. It's actually going to be a compression of a half A. So KMG times. Pretty silly mistake, but at least I caught it in time. Eighth KMGA. So what? Bossing. So 2 minus an eighth KMGA 5/2 MGA. 2 minus an eighth is 15/8 KMGA 2 MGA. K is equal to 4/3. Easy. Part B. Or 7B. Find, in terms of G, the acceleration of P immediately after its release from A. There's obviously some tension. Okay, so T is equal to lambda x over L, which is equal to 4/3 mg times by x, which is 2a at the top. Over 2. No, it would just be a. 8/3 mg. Yep. Resolve second law. 8/3 mg minus mg. So there's only 2 forces. Is equal to mass times acceleration in that direction. Eight-thirds minus 1. 5/3 mg. 7c. Find in terms of G and A the maximum speed attained by P as it moves from A to B. What would the maximum speed be? It's a spring, so it's gonna, the tension's gonna be increasing, so acceleration will be decreased. Acceleration. No, the tension. So as we move towards natural length, so I can get my thoughts to that, the tension is decreasing, so the acceleration is decreasing. So max speed is when tension is equal to mg, so that acceleration is equal to 0. So let T is equal to mg. We have what's mg times some distance, which I'm just going to call BA, where A can be equal to mg. So 4/3 mg, B is equal to mg. 4/3 B is equal to 1, B is equal to 3/4. So 3/4A is the extension, where that's the extension where it's going to be equal to 0. 0. Great. So our initial GP is 0. Initial K is also 0. And our initial EP is going to be, I think it would have worked out 2K MGA, which is obviously 2 thirds, 4 thirds, 8 thirds MGA. And final GPE, the extension is now 3/4, so we've moved 2 minus 3/4 up probably. So we've moved 5/4 up, I think. Yep. I would say our final GPE is that, because it went from an extension of 2 to an extension of 3/4, which is 5/4 difference. Our final KE is going to be a half MV squared, and our final EP is going to be, well, what's, so 4 thirds mg times the extension of 3/4 A, distance 2A, so 4 thirds times 3/4 gives us 1, so MGA over 2A, so half mg, therefore loss in EPE, oh wait, A squared, that's squared, that actually makes a difference, because I was thinking, why is that 1? Is equal to 3/4 mg A squared over 2A, 3/8 MGA. Gain in GP plus gain in KE. Our loss here is going to be 8 thirds MGA minus 3/8 MGA. Gain in GP being 5/4 MGA plus a half MV squared. 5/8 MGA minus 5/4 MGA. Why do we end up with negatives all the time? Wait, no, 8 thirds minus 3/8 is not what I have there. 55/24. Half V squared is just going to be 55/24 minus 5/4. 25/24. Beautiful. Don't forget your GA. So that means V squared is probably going to be 50/24 GA, meaning max speed is this 50/24 GA. Question 7 done. So time to look back at all our questions with 15 minutes left to check our answers. How about that this be? Question 1, I'm fine with, I don't have any issues with that. That one's pretty easy. Question 2, I'm also fine with that one. Question 3, I was unsure, so we probably should revisit question 3. Question 4, I'm totally fine with. Well, part C, I'm not really sure with, but it's fine. Question 5A, I'm very unsure on. Question 6A, I'm relatively fine with. Question 7, I'm fine. So, question 7, we're going to leave. Question 6, we're going to leave what we have. We don't have enough time changing them. We're going to focus on question 5 and question 3. Looking at question 3 again. And then we need to spend 5 minutes on this one. So I have a lot of time on question 5 because question 3 is kind of easy on less marks. If it's deflected an angle of 45 this way, so that means we have negative v instead. So then lambda always has to be -2. That's a given. I'm completely fine with that fact. Mu being a half v minus 2 is okay. But what if lambda was 2? If lambda was 2 instead of being -2, which it could be. Or okay, so if lambda was, let's say lambda was, so negative lambda, negative mu, -2 half v minus 2. That will lead us to what lambda is equal to 2. Mu is still plus or -3/2. But mu would have to be, because of how impulses work, you're going to end up with either, you have to have mu is 2, and that's -3/2. That's one answer. Or your secondary answer could be -2. Because if it wasn't, that means it wouldn't even be hitting the particle, so it just wouldn't make sense. It would be hitting the particle upwards. Well, could it be all values? Because could it just be plus or minus 2, plus or minus 3/2? Okay, let's check each pair individually. So for question 3, possible mu is plus or minus 2, and mu is plus or minus 1.5. So it's either going this way, if it was hit that way, then I can see it. That would mean if the impulse was that way, or it's this way, that would both be able to hit it into a place where it makes sense. So let's take this one for example. You have 2 -1.5. So you would get 2 -1.5 to -2. Aha. That's a problem because 2 is not equal to -2. So if we only take the positive pair, then we just end up with the same answer. But surely you can end up with that, because our momentum formula just doesn't allow for the fact that it doesn't allow for the fact that there could be any change in I, meaning that it has to be -2. So our original answer makes sense. The only possible pairs. Question 4, fine. Question 5, I don't want to have to redo it, but I don't see where I've gone wrong, and that's not really a great thing. Question 5, let's give it our best shot. Let's just read through what you've got. Just find the values of E, because I think we have the correct method. I like the conservation of momentum. 3 + 4, 7 mu. I like equation 1 is fine. Equation 2, we did end up changing one of the signs, so W minus V, and U minus 2U is 3u. So w minus 3, sorry, you'd end up with w minus 3 is 3u, where v is obviously less than 0. Then we rearrange that, so 3u plus w plus v. Substitute that back in. So 5v end up to be negative 6 with 7u minus 6u. And we know that was less than 0, which means that since that was less than 0, and since u is greater than 0, you can divide by u on 5. End up with 7 minus 6e is less than 0. So 7 is less than 6e. So e is greater than 7 over 6, which again is impossible. Because it just isn't possible. Maybe we don't take our 5 out instead. So 6e is greater than 7. Again, that's just not possible. So something has to be wrong with our formula. If I change it to w plus v instead. Hold on. Where's the timer gone? 7 minutes. Let's try redo it quickly. Just on this back page. But having v be opposite way instead, since we know that. Just so I don't confuse myself. Times negative v plus 2 times w. That would end up with 2w minus 3v to 7u. And using more restitution, going that way. Vb being w. And obviously since it's going the other way now, it'd be w minus v. So I'm just going to quickly draw up on top of another v, just so you know that. U minus 2u to 3u is equal to w plus 3. 2. So w is equal to 3eu minus v. 2 lots of 3eu minus 3 minus 3v is equal to 7u. 6eu minus 2v minus 3v is equal to 7u. 6eu minus 5v is equal to 7u. 5v is equal to 6eu minus 7u. So u lots of 6u minus 7. So v is u over 5 lots of 6u minus 7. And yeah, actually no, this is good now, because now we can say that as v is less than 0 and u is greater than 0, minus 7 is less than 0, 60 is less than 7. Still ends up with the same thing. Even though the numbers are different, that makes no sense. 7 minus 60. We've just flipped it around. I don't think I can make any more progress on that one, unfortunately. Just sad, because again, the same answer, even though I flipped it around. So I'm going to leave my final answer as e is less than 6 over 7. So obviously that's possible, and the other one is not possible. And for 5b, well, 5b is here, 2/9. Let's move on. 4 minutes. Just gonna check my answer for 6, and I'm not really that convinced for pretty much all of it. Hope I didn't answer any of it upside down. I probably did. That's fun. I've now run out of stuff to do. I've got an answer to everything. I'm not really sure if I can change anything at this point. Might be better to just leave it, but let me just read through this one more time. The restitution W minus -3. Obviously that's 3 minus -4. You end up with two simultaneous equations, W plus V and W minus, and I'm just going to plug that in again. So you end up with W is -2 over 3, and V is, I don't know why it says V is 11 over 3 and it's definitely not. But if I make that positive one, I make a positive one, and everything. I'm not really sure about that actually, because 0.6 minus 1.6, yeah, that's -1. I'm not really sure on the symptoms equations, so giving me different answers, one of them being positive 11 over 3 and being negative 11 over 3. But negative 11 over 3 makes sense. I think I called that a day. Timer finishes at 2 minutes 9 seconds.
Okay, I was basically like taking notes the whole time because I had nothing better to do.
You took notes on me doing a pass fake. Are you serious?
Well, otherwise I wasn't gonna remember any.
That's true, to be fair. Well,